Hey, I'm recording, I think. We'll see. I think so. All right. So g of x times h of x. Product. How do we take the derivative? Yeah, I love it.
Right, that's right, D left.
There we go. So left, d right, plus right, d left. So left, d right, plus right, d left. Okay? If this was a question where they're asking you to evaluate a derivative and it's a product, if you write this down, you can get a point for that. Okay? So make sure you're writing stuff down and you're not trying to do it in your head. Put it on paper. Okay? One common mistake that I saw last year when I was grading is if you sit and put equal signs, if you were to put an equal sign here and only do half of the derivative, say you started like this, and then you didn't add anything else, they would actually take away all of your points for that. Okay, it's called a linkage error. So just don't put equal signs and then just tell them where your answer is. Okay, equal signs can get you in trouble, so we kind of want to avoid them. And then always make sure you properly mark your answer so we know which solution you're looking at. Okay? Questions on this guy?
I have a question.
Yeah, Hannah.
So this is kind of weird, but sometimes when I'm doing my work, I'll use arrows, just kind of like show myself where the problem, like where I'm plugging stuff in and stuff. That's fine. Okay.
Yep, arrows are good. It's just the equal sign is actually a mathematical statement, so it can make something false. So you have to be careful. All right. So product rule. What about quotient rule?
Low, D high, minus I, D low.
Nice. Okay. Low, D high, minus high, D low, all over low squared. Okay. And again, just writing it out, awesome. And then if we had to plug in points, we could plug those in and evaluate. I think that one might have popped up on one of the practice problems that they've given out. So we might look at that if we have time. Because I could talk all day about calculus. We don't want to talk all day. Okay. Remember with product rule, order isn't super important, but with quotient rule, it is because of the minus. So always start with the low. Okay, so if you remember, product rule is left d right plus right d left. It starts with the L. Same with quotient rule. Low d high minus high d low over low squared. So the test is online, but if you do the work on a piece of paper, you can take a picture and attach it to your test. So you can do all of it on your own paper. You can have up to 5 photos. So you could have up to 5 pages for the problem, upload them, and you're good. That might be easier than typing in the calculus stuff. So, all right. Chain rule.
Outside and inside?
Yep. So we take the derivative of the outside, leave the inside, times the derivative of the inside. I wish there was a cooler saying for that one, but it's kind of boring. Then try to refresh on your derivatives for like your trig functions, your trig inverse, natural log. Refresh on those inverse rules just so you can recognize them and you can take your derivatives quicker. But remember, for those of you that picked up your calculators can do it for you. So keep that in mind as well. Okay. All right. What is a derivative? Just remind me.
Slope.
Slope, okay? So if we have position, that's our original function. If we take the derivative of it, what's the first derivative?
Velocity.
Velocity.
Nice. Okay. Then if we take, we'll call this v of t. If we take the second derivative of position, which is the first derivative of velocity, what's that?
Acceleration.
Nice. Which is a of t. Okay. So if you take the derivative of position, we get velocity. Velocity is also equal to speed. What's the difference between speed and velocity?
Speed has like positive and negative.
Yep. No, switch that.
Velocity has positive and negative.
Yep. So velocity has positive, meaning it's going forward or to the right. Negative means backwards or to the left. Acceleration is derivative of velocity. What happens if velocity and acceleration have the same sign?
They speed up.
Yes. So if velocity and acceleration are both positive or both negative, your particle is speeding up. If they work together, you're going to go faster. Okay? But if velocity and acceleration, can't write, don't have the same sign, now they're working against each other, so we're going to slow down. Okay? So this is asking if your velocity is, or your speed, if it's increasing or decreasing. You just look at those sign changes. Okay, questions on that?
But speed itself is always positive.
Speed is always positive, yes. Like it's kind of neutral, I guess. It's just talking about how fast it's going. Positive and negative doesn't mean anything there. Because you're still going 15 miles per hour if you're going forward or if you're going backwards. Okay, nifty. Can I erase? Yeah, cool. I see one nod of head, I'll take it as a yes. Okay. Maximums and minimums. Okay, I almost guarantee you'll have a maximum and minimum problem. It was on the practice problem that they assigned out. It's similar to one of the problems I've also assigned. So with a max and a minimum, we want to know when the derivative equals 0. Okay, so anytime it's asking for a maximum or a minimum, you want to take the derivative, set it equal to 0. And then we make that first derivative test. Okay? If it's asking for an absolute maximum and minimum, you have to use the endpoints. So we're always going to include the endpoints if we're doing an absolute maximum or minimum. Okay, so remember, we find a couple points, we'll call it C and D, and then we test. Test to the left and the right of your zeros, and then we can tell if we're looking at maximums or minimums. If I start at a point and I increase, that makes this a minimum. Increase to a decrease, this is a maximum. Decrease to an increase, minimum. And then I increase to an endpoint, this is a max. To figure out if it is the absolute maximum or minimum, you have to look at the Y values. Okay? For these types of problems, they're going to ask you to justify. Is it absolute, min, or max? How do you justify that? We're going to put this on a table of values. I'm just going to go like this. A, C, D, and B. Always include the endpoints, and then I'm going to include where the derivative equals 0. Yeah, I already know that D is a minimum. I already know A is a minimum. So I know that they're not going to be the absolute max. But I'm still going to put their values on the table. Okay, so 3, 7, 12, 15. So my absolute max would be here. So if this question asked you, what is the absolute max, justify your answer.
Wait, how did you get those random numbers?
I just pulled them from my brain.
How would you get them on a question?
I'll show you potentially on the practice problem that they sent out. I'll go through questions so we can see that. Are there 2 people there with you, Emily?
It's Camilla.
Oh, hi.
Hi.
Hello. Okay. So for this type of question, if it says find it and justify, this table does everything. Can you see it? It's kind of shadowed. Whee! They're going to give me 1 point for including C. They're going to give me 1 point for finding the answer. And then they're going to give me 1 point for the table because I justified my work. Okay. I'll go through a quick example of that. After we do some review, we'll go into some practice problems. Okay. If this were to move into concavity to determine if it's concave up, concave down, all we're going to do the exact same thing, but with the second derivative. First derivative is for maximums, minimums, increasing and decreasing. Second derivative is purely for concavity. You can also use the second derivative to determine if something is a maximum or a minimum, but first derivative does the trick pretty quick. So I would just stick with the first derivative unless they ask a concavity question.
Which one's concave up and concave down again?
If your second derivative is positive, it's concave up like a cup. If your concavity or your second derivative is negative, down like a frown.
And are you taking the derivative of an equation we would get, or is it just based on what we see here in the table?
So you would just take the second derivative, you would take the derivative of the first derivative. So you would have to have an equation. Or if they gave you a graph, you could see visually that concavity. Okay? Oh man, there's just so much review stuff we could talk about. But hopefully we'll visit some of it in some practice problems. We'll just talk basics now. Maximum, min, concavity, first derivative. We already talked, so yeah. I don't think it'll be on there. We'll be okay. All right. Integrals. So our integral, remember this kind of just tells us area under the curve. My brain just shut down. There was a word I wanted. Integrals, area under the curve. Oh yes. This is also displacement. This one's going to come in handy for the questions where it's asking, like the practice problem that we're going to go over here quickly. The displacement, how much water drained out of the tank. There was a question on a previous exam that said, based off of the rate, how many bananas did they restock? How many bananas were sold? Anytime they want, given a rate, and then they want an amount, we're looking at the displacement. So we'll go over that practice problem on the most recent assignment here in a second. How do we solve integrals?
Antiderivative.
Okay, we're gonna take the antiderivative. Those of you that checked out the calculator, or if you have the calculators already at home, or you downloaded the free TI off the internet, your calculator will do any integration for you, okay? So, but like they said, the test, you won't need it, so you should be able to do it by hand. They'll be nice questions. Okay.
Will we have to do use substitutions?
Might have to, yeah. Okay. Since we're not doing any of our solids, we are just doing displacement with integrals. That's about all there is until we actually look at it in practice. Okay? How many of you have done Corona practice number 3? Okay? How many of you would like me to just go over it right now? Decent. The rest of you that are just names, I don't know if you're saying yes or no, so I'm just saying we're doing it. All right. So for those of you that don't have that, if you want a screenshot real quick, I'll show you. Oops. Okay. This is the problem that we're going to be going over. So if you don't have it already, you could go ahead and just take a screenshot of it so you can kind of have it chilling next to you, looking at it for a second. This is what we're going to be talking about. All right, I'm going to quick copy a little bit here. All right. Okay. So what I have here on the board, I just quick jotted down the table and the W of t. So that function that they gave us. Okay. So it says water is pumped into a tank at a rate. So this is the water that is going into the tank, and it is a rate. It is important to know that it's a rate because that tells us that this is a derivative, okay? Then water is removed. So this is moving out of the tank. And again, it's a rate, so it's a derivative. And then they've given us, at time equals 0, we have 50,000 liters. All right. Any questions from that? All right. This is so awkward. I have to keep jumping back and forth. So the question, part A, estimate R prime at 2. Okay, part A, R prime of 2. What does R prime represent?
A derivative?
Perfect. It wants a derivative of R at 2. R is from our table. We don't have a function. We can't take the derivative of R. What does R prime, a derivative, represent? What is a derivative? Slope, okay? So all I'm gonna do, since we don't have a value at 2, I'm going to estimate by finding the slope from 1 to 3. Okay, so I'm gonna go from 1 to 3 and I'm gonna find the slope between these 2 points. So I'm gonna take 950 minus 1190 over 3 minus 1. Okay. So 950 minus 1190, I get negative 240. 3 minus 1 is 2. So that gives me negative 120 liters per hour squared. Why is it hours squared? Okay, because it's a second derivative, right? This rate is liters per hour. So if I take the derivative of that, it's hours squared. Okay. So given a table, we can estimate a slope by just taking the slope of the line. Okay. Questions on part A? I should be able, I know I've got it pulled up somewhere. Maybe. I'm just gonna see point-wise, but I don't think I have it pulled up quick, so we'll worry about that in a bit. All right. Part B. The question says, use a left Riemann sum with 4 subintervals indicated by the table to estimate the total water removed during the 8 hours. Is it an overestimate or an underestimate of the water removed? Give a reason. Okay, so we're doing an LRAM here. They want, for the full 8 hours, 4 subintervals. So there's 1, 2, 3, 4. So all we're doing is finding the area of the rectangle from the left. So my height here is 1340, and it has a height of 1. So 1 times 1340 plus, using the left value, I'm using 1190, and my base from 1, what was that? Nothing? Okay. Then my next one is 950 with a base from 3 to 6, which is 3. So 3 times 950 is the area of that rectangle. And then my last one is the 740. And it has a base from 6 to 8 of 2. Ethan, type it out. I can't hear you. Okay, if this was a question on the test and they wanted to know what this was, if you write that line down and don't do anything with it, you will still get all points for that. Okay? You don't have to simplify. I could leave this as is, and I will get those points. Can we see it? Trying to block the sun a little bit. Okay. There was a second part to this question. It said, is it an overestimate or an underestimate? If you go back to the main problem, so I'm just going to show it to you again here. Right here where it says R is differentiable, meaning it's continuous, and it's decreasing. Okay? With it decreasing, if we come in from the left, what's true about our estimation?
Overestimate.
It is an overestimate because R of t is decreasing. If it were increasing, it would be an overestimate. So if it's talking LRAM, RRAM, or MRAM, just use LRAM, the left side, RRAM, the right side. If it was an MRAM, we would only be able to use the 1190 and the 740 because that's middle. All right. C and D are the fun ones, so let's take a look. Any questions on these ones so far? Okay. So this next part is definitely a calculator part question. Part C is asking to use your answer from part B, which if you had typed that into your calculator, part B, we would have gotten 8,050 liters. Was it 8,000 or was it 6? It was, okay, 8050. We're gonna use that answer and we are gonna find the total amount of water in the tank. All right. How frequent, trapezoid. They could ask for a trapezoid question. I don't know how frequent they are, but remember the only thing that changes with trapezoid, if you're using the table, you just do height over 2. Base 1 plus base 2. Davu, did you have a question?
No, sorry.
No,
I
you're
was
good.
just saying I don't know.
Okay. So remember how I just told you on part B, you don't have to type that into a calculator, but then part C is saying use part B? You could have said on part B, type that whole line, and you could have said this value equals A. And then you could use A in part C without actually knowing this value. Does that make sense? Okay, so if you did type it into your calculator, we got the 8,050 liters. Part C is asking, what units would you use if we, same units, but you would have used MRAM. This would have been your height for MRAM. Because you could only go from here to here, this is the middle point. And then from here to here, there's your middle point. So for MRAM, you'd only use the 1190 and the 740. All right. So we have a tank. They told us we already have 50,000 liters in the tank. And then we have water that is flowing out of the tank, and we have water that is flowing into the tank, right? Okay, so I'm going to start out with 50,000. Then I'm going to add the water that's flowing in, and then I'm going to subtract the water that is flowing out. We already know how many is flowing out. That was part B. So I can just say minus the 8050. Or if I had labeled that A, I would just say minus A. So we need to figure out how much water went into the tank. We know the rate at which water is going into the tank. So we need to find the displacement. Displacement is your integral. And we're going from 0 to 8 of WT dt. So what this equation right here is showing, this is where we started. I started with 50,000. This much is flowing into the tank. This much is flowing out of the tank. Okay, we know what W of T is. They gave us this equation here. And so all I would do, once I've replaced this with that equation in my calculator, I'm going to type in 50,000 plus the integral from 0 to 8 of 2,000 times e to the negative t squared over 20 dt minus 8,050.
And would you have to add all that out, or could you just circle that?
If you wrote this down, you would potentially get one, you might get all, because it's not wrong. Let's see, the question asked, use your answer, find the estimate total to the nearest liter. I mean, that is correct. It just makes you do the math, or it makes the grader do the math, so it's not wrong. Huh.
If I don't have an Inspire at home, what do I need to download on my computer?
If you go to texasinstrument.com, they have a free TI download. So you can download like an 84 or an 86, and it'll work just fine. It'll work. Didn't you have a calculator in class? Abby, I have no clue what you just said. Type it out. Let's see here.
Can you hear me now?
Yes.
What I just said was I don't remember how to do it, so I can probably just look that up.
Okay. If you typed this into your calculator, if you tried it out, this gives you 49,786.2 liters. So if you typed that into your calculator, this was the value that you would get out. So 49,786.2. And here, they would even, like, I know the point wise, they're going to give you a point for setting up the integral. They're going to give you a point for using the 50,000, and then they're going to give you a point for the answer. So to answer, I think it was Debu that asked, if you had just written that down, the worst that would happen is you would lose this point, but I don't think you would. All right. Question?
One more question.
Yeah.
How would we know to use an integral?
Because they've given you the rate of liters, and then they want to know actual liters. That means we're going backwards. We're going from a
Okay.
to a liter, so we have to go backwards, which is an integral.
Okay.
Okay? All right. Part D was my least favorite part of this problem. So on part D, if we read it, it says, for any time from 0 to 8, is there a time when the rate at which the water is pumped into the tank is the same as the rate at which the water is removed from the tank? Explain. All right. So the real question is there any a point where W of t equals R of t?
It would be yes. It would be yes, right? Because one's decreasing while the other's increasing, so they would cross at some point. Isn't that all you'd have to say?
Your logic sounds correct. So if this one's always decreasing and this one's always increasing, is there a point though that they were already below so they never meet?
That is also a good point.
Okay. One easy way to tell if something is equal is if you subtract it from the other and it equals 0. Right? Okay, I need to know, is there a point when they're equal, meaning if I subtract the water in minus the water out, I get 0. Okay. So again, my least favorite part, what we're looking at here is what happens at the start. So what is W of 0 minus R of 0? So if I start out at 0, the rate at which the water is going in minus the rate of which the water is going out. W of 0 is 2,000. I plug in the 0 here. E to the 0 is 1 times 2,000. R of 0 is 1,340. That gives me a positive solution. Okay? So what that tells me is at this point, the water is going into the tank faster than it is going out. Someone just came home. That sounds like my dad. What you doing, Dad? Okay. All right. Then, so that started at 0. Now we're going to look at the end, at 8. So I'm going to do the same thing. W of 8 minus R of 8. Bye, Dad. Okay, W of 8. Here, I'm going to need a calculator. If I plug in 8 squared is 64 over 20, e to the negative 64 over 20 times 2,000. That's going to give me 81. Again, I plugged 8 into W of t. And R of 8 is 700. (81 minus 700), that is a negative number. Agreed? Okay. Why do I care if this one's positive and this one's negative?
Because that
Because at
means
some point
they
it
cross.
change.
Yeah, if we're looking at a graph, to go from a positive value to a negative value, I have to cross 0 at some point. So, yes, there is a point in time where W of t equals R of t, because this function changes from a positive to a negative. And literally, if I wrote that down, so if I'm going to erase this real quick, W of t minus R of t, how'd I write that? I did that. W of t has to equal R of t at some t, because W of t minus R of t changes from a positive to negative. Real wordy kind of answer, but it has to be equal because my function W of t minus R of t changed from a positive to a negative. To prove something equals 0, well, prove that at some point it was positive and then at some point it was negative, or vice versa. It has to cross 0. Not my favorite, because it's one of those that seems so easy, it makes it a little bit hard. Okay. So that was the third corona problem that I assigned. I had the first 2. We can go over a couple questions if you guys want to for those. But do you guys have any questions here on number 3?
Could you go through taking the integral with 50,000 plus the integral of W dt, W t dt, take away 80/50? Because when I plugged it in, I kept getting the wrong answer. So yeah.
So doing the 50,000 plus the integral from 0 to 8 of 2,000 e to the negative t squared over 20 dt minus 80/50. So in your calculator, it depends on how you type that in. Did you come and get the new one, or what calculator are you using? Okay, so when you pull up that integral symbol, just make sure, I think your only downfall is making sure you've plugged that part in properly. I'm clicking on your face. How do I get you to come up? Whee! I don't know what that button does. I don't want to do that. Show me your calculator. Ooh. And that's not giving you the right answer? Why can't I unmute you?
There you go. Sorry. Totally forgot I was still muted that whole time. I got like 1.61931 e to the 21 or something.
When you hit enter, go ahead and hit hit tab, hit the blue, and then hit enter.
No. Okay. Here we go. Answer. It just changes it back. It like does it really long and then makes it back to the short one again. I also don't know what that's.
Let's see here. Times e to the negative t. Is that a divide by 20? It looks like a minus 20.
Oh, yep. I did that wrong that time. Okay. I know higher up. Oh, wow. I kept doing minus 20. Okay, that's probably it. Thanks.
Cool. Yep. Easy fix there. All right. So we were talking about one of the graphs. I assigned this problem. So where's this button? So many buttons. So this was one of the problems that I assigned. And this one is really good for understanding the relationship between integrals and the graph. The practice problem that AP assigned does something very similar, and it really helps show the relationship between a function and the integral in the graph, I guess.
Which practice problem is this?
I want to say that this one was practice problem number 1.
Yes.
Thank you. All right, I'm gonna have to sketch this graph real quick. For those of you that are chilling here, if you've already done the problem and you don't want to see me review it, I mean, you don't have to stay. You're here as long as you want. If you guys have specific questions, you can email me. I'll be responding. We could even do another quick meeting tomorrow morning since the test is at noon. Get you all pumped and ready. All right, I'm gonna sketch this real quick. Okay. Whoa. Who's drawing on their screen? It just drew on my screen. What's happening? That's not possible. All right, can I stop sharing that? Y'all got it? Okay, a couple people said yes, so that's fine. Okay, so we're looking at this graph, real high tech here. And they told me that this end portion is the function 2 times x minus 4 squared. Okay, part A wants to know what if f of 1 equals 3, what does f of negative 5 equal? All right. This is the graph of g, and they told me that g is the derivative of the function f. So g equals f prime. Knowing this relationship is vital, okay? Graph of f is the derivative of f. So if we know that f of 1 equals 3, that means right here at 1, our y value is 3. So what we're going to do is we're going to take the integral from 1. Yeah, I'm going to post this probably to maybe both YouTube and Canvas. I'll figure out how. I can figure it out. So I'm putting 1 at the bottom of the integral because that is my initial condition. Okay, so I'm basing everything off of this 1 because that's what they've given me. So I'm going to go from 1 to -5. Okay, of g of x dx. This is going to give me the displacement from 1 as I go backwards to -5. So again, they're asking for a value of f, and they've given me the derivative. To go from a derivative to a value of f, we have to take the integral. So that's what we got here. Okay, we're going backwards, and our integral is going backwards. So I'm going backwards. I think we're going to add. Nope. Yeah. We'll see. We might have to subtract that. I need to look at the problem when we get in there, but let's just check it out.
On the thing, I think you said subtract in the
I
video.
did? Okay. My brain just has to play with it a little bit after I find the value. So when we find the integral from a graph, all we're doing is finding area under the curve. So right here at 1, we have that small triangle. I'm trying to get this closer. Whee! Little glary. Oof. Okay, so I'm trying to get this small triangle right here. So it has a base of 1, a height of 2. So that has a 2. But I'm going backwards, so it's technically negative. This piece right here is just flat, so it's just 0. And then I'm going to add, because I'm going backwards and it's negative, this piece here. You could either split it into a triangle and a rectangle, or you could treat it as a trapezoid.
Don't you have to divide that little triangle by 2?
Yep, thank you. Thanks, Abby. Okay, so I'm just going to double check since it's just a sketch. So this is a 1 by 3. So that's a 3/2. And then this is a 3 by 3, which is 9. Okay. So if I do the math here, this ends up giving me 9.5. No. 1/2. 9.5. Yeah, I definitely want to add that. So let me explain why I want to add. If I start here and I have some unknown y value, I'm going to subtract, and add, and I'm going to get to 3, right? So I'm going to take 3 and I'm going to add this onto it because that's where I started. So that means I'm starting out at this point My y value is 25 halves. And then I subtract 9, subtract the 3 halves, add the 1, and so at this point, my y value is 3.
I have a question.
Yes.
So why is like the 1 negative even though it's like above that, and then the 3 halves and all that is positive even though it's under the line?
Because I'm going backwards, I'm taking into account the negative and the negative. So
Oh,
because I'm here and I'm traveling back,
yeah, okay, that makes sense.
okay? So I'm making this negative and I'm making this positive.
Okay. Is it always like
If I didn't take into account that I was going backwards, then I would subtract. And then I would go from -5 to 1. This would stay negative, this would stay positive. But it's because of that flip.
Where did that 3 come from?
The initial condition right here. They told us that at 1, our y value is 3, our initial condition. So that's from the problem they gave us that.
So basically, if you go backwards, you'll add, but if you go forwards, you'll subtract.
Yeah. Well, you just keep the signs as is.
Gotcha.
Yeah. So if I would have just kept this as a positive, then I made this negative positive. If I was going forward, I would add and I would keep the signs positive, negative. Okay. If we were traveling in the other direction, so if I was going from 3 to 6, I'm going to add to the 3. So 3 plus. What we're finding is our displacement when we do the integral. Right? Okay. Part B, evaluate the integral from 1 to 6. Okay. Abby, we can chat later if you need to. I'll do my best. Okay. This just says integral from 1 to 6. That means find the area under the curve. So from 1, I think that's to 3, right? Yep. From 1 to 3, I can do that geometrically. That's just a nice box, right? That has an area of 4. But this piece, we're now going to go from 3 to 6 of 2 times x minus 4 squared dx. We're going to have to do that one algebraically. Can you guys see the bottom of that? I've been moving it around a lot. Okay. So again, I split it because this piece is nice and geometric, but now I'm dealing with the parabola, so I'm going to have to do that one algebraically. So the area from 1 to 3 is 4, and then the area from 3 to 6, I'm going to anti-derive this integral. We would think that this is a u substitution because we have a function inside of a function, but because the function inside is just x minus 4, we don't have to worry about it because what's the derivative of x minus 4?
1.
Yep, it's just 1. So I'm just going to anti-derive. 2 times x minus 4 cubed over 3, evaluated from 3 to 6. Okay, So 6 minus 4 is 2. 2 cubed is 8. So that's 16/3. Then I'm going to minus, if I plug in 3, 3 minus 4 is -1. Cubed is -1. So that's a -2/3. So I'm going to minus a negative. That becomes plus. So I'm going to jump up here where I have a little bit more room to kind of write this. I have 4 plus 18/3, which is 4 plus 6. We're at 10. Okay. Questions on that one?
How were you able to count the integral as from of x minus 4 squared times by 2? How are you able to find that integral without squaring the function?
Because the function on the inside, its derivative is 1, it doesn't really have a chain rule. If this would have been a 2x minus 4, then I would have to do a u substitution or FOIL it together first. But
Okay.
because this is nice, I don't have to do that.
Okay. Thank you.
Yep. But again, if this was on the test, would you do that by hand? You can, but if you have a calculator, do it. Let the calculator do it. They just want the answer. If you wrote this down, you're showing the separation there. That's good enough. Like that would get you points. I would prefer to take it a step further just to prove it. Get the 4, get the integral, you're set. All right, part C. From -5 to 6, on what open intervals, if any, is the graph both increasing and concave up? All right. So I've drawn all over this guy, so let's clean it up a little bit. All right. This is G. G is the derivative. The derivative tells us increasing and decreasing. Where is my graph increasing?
It's positive.
Yep, when it's positive. Anything above the x-axis is increasing. Anything below the x-axis is decreasing. So the question is asking, where is it increasing and concave up? Well, the only place it's increasing is over here. Concave up is the second derivative. So where is the second derivative positive? Now we're looking at the derivative of a derivative. We're looking at actual slope now. Where is this increasing? Right here and right here. So where we are both increasing and concave up from 0 to 1, and then I think that's 4 to 6.
And why is it
Sorry,
that we need to use that?
What?
Okay, I was asking why is it that we use the brackets there on the end instead of parentheses, or how do you know when you need to use it?
If the 6 was included, it would have to be continuous. but we can't take the derivative of an endpoint, so that's why I changed it to a parenthesis. How do I explain this? The question is if it's included. Here at 0 and 1, they're not included because I can't take the derivative at corners. Okay, it's not included at 4 because it's 0 at 4, so it's neither increasing or decreasing, it's 0. And then 6 is an endpoint, so I can't take the derivative, so it's also not included. Does that make sense? If this piece, whoops, right here at 4, if this was lifted, that would be included because it's positive, and nope, then it's still 0. Just kidding. It just wouldn't be.
Sorry, I must have missed something. How did you get concavity?
Concavity, we're looking at the derivative. I'm just looking at the slope now. Where is it increasing? Literally increasing, going up. So concavity is the second derivative, so we're looking at the slope of the derivative. A line has no concavity, correct? But remember, this is a derivative. We don't know what the original function looks like. So the original function is concave up. But right here, it's just a straight line indicating an increase. Okay?
So if you were given the original to find concavity, you'd have to take the derivative?
If you had f of x, if you were looking at it graphically, you should be able to see the concavity. But if you were given a function of f to find concavity, take the derivative twice. All right. Part D. It says find the x-coordinate of each point of inflection. Oh, one sec. Let's go back to part C and finish that one. It said explain your reasoning. How do we know it's increasing and concave up? Because g of x is greater than 0, meaning g of x is positive above the x-axis. And then g prime of x was also greater than 0 or positive. The derivative of g, the slope of g, is increasing. And if you've already put this on the graph, you have to know this to be able to understand part C. That this is the derivative of f. So f is increasing and concave up because g is positive and g prime is positive. Okay. Part D, we're looking at points of inflection. Points of inflection is when the second derivative equals 0, or when we see a change from increase to decrease, decrease to increase. So if we look here, I have a decrease to nothing, an increase to nothing, an increase to nothing, a decrease to an increase. So my only point of inflection is at 4. And the reason that that's my only point of inflection is because G prime changes from a negative to a positive. Points of inflection are when the second derivative equal 0. When we see the second derivative change from increase to decrease or decrease to increase.
What's it called then when there's like a corner or a jump or where you just have no derivative?
A discontinuity?
Yeah. Okay.
Or it's just not differentiable at those points. All right. So, again, AP has sent out a practice problem. They've kind of manipulated some previous questions. They're saying, try this. This is something to help you study. If you guys want to look at that sometime today, I will post a video of me doing that problem. And then tomorrow morning, we can go over clarifying questions. I'll create another Zoom. You guys can come in, ask any final questions. The test is tomorrow at noon. Okay. I will go ahead and I'll take what they have sent out. I will put it up on Canvas so you guys can have quick access to that practice problem. And they've also recommended a couple others to look at. I'll post all of those with them as soon as we get off here. Okay. Any thoughts, questions, concerns?
I was wondering if we're gonna have like a final, or I guess how is grading working for this term?
Let's be real honest. If any of you guys noticed your grades updated the other day, you guys all have straight A's. I've been looking, a few of you have actually been killing it on Khan Academy, have almost like completed the whole calculus unit, which is awesome. But I've been posting the things. I didn't want to have to grade all of them by hand, so I didn't want you to turn them in. So I'm just assuming you guys are doing what you need to do and you guys are all getting passing grades.
Okay, thank you.
Yeah, you're welcome.
So I just want to like double check, but like if we choose not to take the AP test, it's not gonna affect anything?
Nope. So if you don't take the test, you're totally fine. And if you don't take the test tomorrow, like literally you just don't sign in, they will refund you in July.
Okay, thank you.
Yes. I'm trying to decide if this test is actually like a blessing, because I think they might be relatively nice with the grading, but it's also kind of a curse because it's totally different than what we were expecting. So we'll see how it all goes. All right. I'll ask Isaac and see if he's willing to hang out with anybody and break the honor system. Honestly, I think if you do the practice problem I'm going to post and you do the Riley, I'm sure would do it too. If you do the practice problems, literally have them on paper sitting right next to you. This is open note, just not open Riley or open Isaac. Open note. So all of the stuff we just did today, have it next to you. Do the practice problems. Go online and look at my YouTube videos and just copy down what I wrote. And then you can just be like, oh, this problem looks like that problem. I'm just going to write this down and see what happens. So, okay, but let's just do it over Zoom. Yes, that'll be great. Esther's not going to cheat. Isaac might come over and do it with her. I'm sure he would enjoy it, actually. All right. So I'm going to go ahead and close this. I'll post this, and then I will post the practice problems that they told you to practice. No, Mazar, we can't do it over Zoom. I miss you guys so much. I hope you guys are all staying safe and staying healthy. Next week, Monday, Tuesday, and Wednesday, they're doing the come back to school, collect your supplies, all that. Please swing by and say hi. I will have my puppy there with me because I can't leave her home. So you guys can meet my dog.
Question?
Yes.
Is the class kind of done as soon as the test is done?
Pretty much.
Okay.
The last day I can assign anything is the 12th, which is tomorrow. So we've survived. We have survived. Okay. See you guys. Miss you.
Thank you.
See you next week. Please come by.
Thank you.
Thank you.
Hey,
Yes.
Thank
miss
you.
you.
Wait, what times next week?
Wait,
The
Miss Nel-
school's open from 8 to 3, and I think they're gonna send you a specific time where you are supposed to come in.
Oh, okay.
Miss Nelson.
Yes.
We take the test on the college thingy app, right? Thingy.
Yeah, you're gonna be taking it on your like your AP classroom.
Yeah.
Yep. So you're just gonna need your AP number.
What?
Do you know how to find your AP number?
I don't think so.
So have you logged
They
in?
should have sent you an email. There
Okay.
should be an email with the number on it. They were supposed to send it 2 days early, I think.
Okay. Mishar, go ahead and log into your AP classroom.
Okay.
And it like you can click on Miss Nelson's calculus section and your AP number will just be listed right underneath the heading. And if you guys haven't already, log on and try to do the practice, the demo, so you can upload the pictures quickly.
AP calculus one. AP classroom.
Yep.
I don't see it. I see the practice exam test.
So that it's posted there, you can see it.
Yeah.
Cool. So I'm gonna send a link to Canvas too, so you can see it there. Do you see your number?
No, I did not see the number.
Did you click on the calculus actual classroom?
Yes, I did, man.
It's not on the right side of the screen.
Try my computer. I was using my tablet.
If you can't find it, email me. I might be able to log into my classroom and find it for you.
Yeah, thank you very much.
Yep. You guys are lingering. Do you guys have questions? Just hanging out? Just waiting to say goodbye? My mom made sure that the kitchen was clean. She was embarrassed I was going to be broadcasting this to the world. And this wonderful easel, it's kind of ruined. I'll show you the actual whiteboard. Oh. That's from all my nieces and nephews. We've had this easel since I was like 5 years old. So I'm in full circle now. All right. Miss you guys.
Missed you.
Bye.